Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video explains the reason why optical length measurement is superior to other methods, covers the two different methods used to determine fiber length, along with the advantages and disadvantages of both. Along with connection loss and splice loss, fiber loss is one of the key components of any insertion loss measurement. In order to determine the acceptable amount of insertion loss for the fiber under test, the length of the optical fiber must be known. Length can be determined a variety of ways. One way is to look at the footage markings at the ends of the fiber link. This method falls short when jacket markings cannot be found or if it is suspected that there is a splice or an interconnection mid-span. A second way to determine the length is to walk off the length with a measuring wheel, although this method is inherently inaccurate when the pathway is partially inaccessible or is installed vertically, as is the case with riser cables. If previous installation documents are available, they may also be used. However, the most accurate and reliable way to determine the fiber length is to use a device to measure the fiber path optically. In general, fiber length is measured by transmitting light into an optical fiber, which triggers a timer in the length tester. The light travels to the end of the fiber link and then returns to the length tester, at which time the timer stops. The total round-trip time is converted to distance using a preset index of refraction value. Index of refraction must be set correctly to ensure length measurements are correct. There are two methods for measuring length. The first method is called reflective. Reflective length measurement is how OTDRs determine distance. And this can be used not only to find the end of the fiber, but also to find any events as far as how far away they are that are present in the fiber link. This method only requires one fiber since the transmitter and receiver are present in a single OTDR port. The drawback to reflective length measurement is that fiber end detection is not foolproof for two key reasons. First, echoes could make the fiber appear to be longer than it actually is, and second, breaks could make the fiber appear to be shorter than it actually is. The OTDR trace must be visually analyzed to determine which event is the actual end of the fiber. Round-robin length measurement, on the other hand, is a bit more cumbersome than the reflective method since it requires a transmitter and receiver in separate ports and using two fibers to make the length measurement. However, round-robin is practically foolproof as long as both of the fibers have sufficient continuity. A fiber could be almost completely broken and still allow light to travel through the break. After all, light can travel through a broken window. In addition, round-robin measurements are very accurate and even more accurate than OTDRs. OWL optical length testers such as the Fiberall 4 Bolt, Bolt NL, and Volt use the round-robin length measurement. For the purpose of fiber link certification, optical length testers are preferred due to their superior accuracy and low cost. While these devices can accurately measure total distance, the round-robin method does not allow for distance to a fault. Only OTDRs are able to measure distance to a fault. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos, or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.